Okay, 6.5, logarithmic properties. This is very much a section that is kind of building into the next section. So you might kind of be thinking, okay, I kind of get why or how this works, why we're able to put things together and take them apart, but I don't understand why we're doing them. Well, we're going to use them heavily in the next section. So this is kind of an introduction. So we mentioned, and I've probably mentioned at least 10 times at this point, that logarithms are related to exponentials, and they're related specifically that they are inverses of each other. So when we get into these logarithmic rules, I'm going to say we're going to recall what the exponential rules, maybe we didn't explicitly say the exponential rules in this course, but hopefully you've seen these exponential rules before. We're going to state the exponential rule that it's related to, and then we're going to talk about the logarithmic rule. So with exponentials, if they have the same base and we're multiplying them together, what we do is we add the powers. So to do the logarithmic property of the product rules, if we are multiplying the insides, or the inputs of my log, then I'm adding the outside logs. So it's almost reverse. If I'm adding logs, then I can multiply their insides, versus with exponentials, if I'm multiplying their outsides, I can add them together. For the quotient rule, if I have an exponential and they have to have the same base, then when I'm dividing, I subtract the powers. Well, maybe you can understand what the rule is going to be. Log b m over n is equal to subtracting the entire bases. Now, I think I've said twice on the exponential rules, but the bases do have to be the same. So if you're using the product rule or quotient rule, and it's for exponentials or logarithms for that matter, you have to make sure all of the bases are the same. So if they don't have the same base, in this case, both of the rules have log base b for all of them. But if those were like log base 2, two of them were log base 2, and the third one was log base 3, you actually can't use the property. So make sure you're kind of checking that. I don't think we're going to try and trick you with that in this course, but it is something to be aware of in future courses, that you can't really use these rules if you don't have the same logarithmic base. Now, the power rule, there isn't really an equivalent power rule in exponentials. I mean, technically, it's just using the product rule ad nauseum. So we're not going to talk about its relationship. Instead, we're just going to post directly what the rule is. And the rule is that if I'm taking the input to a certain power, I can kind of bring that power to the front of my logarithm. And vice versa. If I'm multiplying something by my logarithm, then I can bring that in as the power of the input. So we love, and not just we, almost every school kind of loves this ability to kind of expand and put together logarithms, because it's showing that you kind of have some fluency involving how to use these properties. So that's exactly what we're going to get into. And as I did mention, this will seem kind of isolated and strange. There is value to both of them, and we will see that in the next section. So in order to expand, I'm going to be undoing these rules. And so I see that I have this division problem. And so looking back at the last slide, okay, I can use the quotient rule then. It looks a little bit scarier, but I just have a bigger m or a weirder m and a weirder n, but the process still works. So I'm going to subtract the numerator from the denominator, and I'm going to keep the log bases the same. And then I'm going to keep going. When you're expanding, the goal is to kind of have just one factor in each logarithm. And also you don't really want to have powers, because if you do have a power, that's almost like you do have two factors in it or multiple factors in it. So now I'm going to use the product rule, which says that if I have things multiplied inside my logarithms, I can kind of split them up and make them addition. So my first logarithm would split up into be x squared plus x plus 1. I'm undoing that product. And my second log would become log base 3 of 3 plus log base 3 of x minus 1. And it's important to put that in parentheses because you're subtracting that entire log. Yes, we're using the log property to split them up, but that whole thing that we split up was negative before, so it has to remain negative. I don't think I did anything in that step, kind of weird. Next step, I distributed my negative to both terms on the right side. And then I did kind of 2 steps in this last before getting to my answer. So I don't want to have a power, so looking at that first log, I'm going to use the power rule, bring the 2 in front. And then the only other thing I did in this line is you may have noticed that log 3 of 3 is gone. And that's because I think it was 2 lectures or maybe 3 lectures ago, we saw that if the log base matches the input, that's just equal to 1. So that's kind of just like the icing on the cake, that if you get to this last step of expanding a logarithm and you have the base matching the input, you would put 1. If you have the base and the input is 1, then you would write 0. So just kind of watch for that. If there is just a plain number left and there isn't really like an X or something on the inside, there's a decent shot that you can kind of simplify that guy a little bit further. Now, that's expanding logarithms. That is valuable. There's a lot of things going on. So if I were you, I would watch a slide, kind of stop at each step and say, oh, do I understand what he's doing? Okay, use the quotient rule. Great. Okay, do I understand what's happening? So that you can kind of track. Because like I said, this is a very popular question. I don't think we have another take-home test left, but we certainly do have a final left. And if I were a betting man, I would say there would be one question like this and one question like the next slide that would be on the final. Now, compressing logarithms. Compressing logarithms is kind of a weird way of saying that we're going to take this expanded form and we're going to go backwards. We're going to try and compress it into a single log. So your first step in this one is kind of the last step in the last slide. If you have something in front of your log, you're going to want to take it into the power. So the last step on the last side was if we have a power, we bring it out. Now we're going to be undoing the process, so we put it in. So I'm kind of looking through this expanded logarithm. I have 2 logs that have something in front of them. One is 0.5 and one is 3. So I'm going to bring them to both powers, or both inputs. So my second logarithm becomes log x to the 1/2. My last logarithm becomes log x minus 1 to the 3rd. Now x to the 1/2, and this one is probably digging into a lecture, I don't even know, maybe 10 lectures ago, that if I have a fraction, like 1/2, that's square root. If I have 1/3, that's cube root. If I have 1/4, that's fourth root. So I am just going to kind of write it as a square root. Probably wouldn't dock you if you left it as a fraction, but it is kind of good to note the difference between the two and how typically when we're writing things and simplifying them, we like to leave it in that radical form. Okay, so all of that was really just a long kind of first step. If I have something in front of my logs, I want to bring them into the power. And now I want to use that rule of, okay, if I add things, I multiply them, and if I subtract things, I divide the whatever my input is. So in this case, what did I do? Oh, I combined my first 2 logs. I did log 5 plus log square root of x is log 5 times square root of x now. And if I'm adding logs, I multiply their insides. And then I combined the first 2 logs together, 5 root x divided by 7x minus 1. Since I was subtracting log 7x minus 1, I divide them. And then I'm going to apply the product rule one more time. I'm adding log of x minus 1 cubed. So if I multiply that by my fraction, that will show up on the top of my fraction. Now, a bit of a shortcut that we can use in the future is that anytime that I have a positive, I am multiplying. Anytime that I have a negative in front of my log, I am dividing. So really I could have looked at, let's see, line 3 there, and seen, okay, everything that is positive is multiplication, everything that's negative is division. So anything that is positive is actually going to show up on the top of my fraction, and anything that is negative is going to show up on the bottom of my fraction. So that kind of could have saved us a couple steps by just looking at line 3 and saying, okay, 5 times root x times x minus 1 cubed, because those are all positive, and that's going to be divided by 7x minus 1. If you don't like that shortcut, or that shortcut's not tracking, you can go through these steps. It's honestly not that much more work to go step by step, But that is a nice, neat little trick. And that's also not a bad trick to kind of do in the reverse as well, that if you are expanding this logarithm, anything that is on the bottom of your fraction should have a negative in front of it when in its expansion, and anything that is on the top of the fraction should have a positive log, or positive sign in front of the logarithm. And yeah, there isn't any bases on this, but we kind of know that if there is no base specified, it is log base 10. So even though it seems like these are kind of just vague logs, the bases were the same, so I was able to do this. And that was true in the last slide too, that the bases were the same, so I'm able to use this process. But be aware of maybe sometime in the future, especially if you're going into calculus, there might be a case where you have to check to make sure that the bases are the same. Or maybe you have to combine two separate logs. Change of base, we actually talked about this, I think 2 lectures ago, but we didn't actually get into using this. So how change of base works is, yeah, this day and age we have fancy enough calculators that we can kind of just throw in logs and we don't need to worry about it. But some of the older calculators or the older graphing calculators only have log or ln as a log button. So in order to evaluate it, you would have to use the change of base formula, which says if I have a log base 5 of 100, that's the same thing as log of 100 over log of 5. Or it's, did I write it? Yeah, or it's the same as ln of 100 over ln of 5. Either of those are fine. You could throw them in your calculator. You would evaluate to get 2.86. That's the end of this section.